Welcome. Here we're ready to talk about concavity and points of inflection in this video. Concavity has nothing to do with the dentist, at least not anything directly. And inflection, you can kind of take your own meaning for the word inflection. We're going to have our own meaning to go along with it. We're trying to understand it from the point of view of calculus. So first consider a function. Y equals x cubed minus 5x, and then right underneath we have a nice little picture of that function. We can see it curves up, reaches a relative max, a little bit between negative 1.5 and negative 1. It comes down and reaches a relative min, again between 1 and 1.5. So that's what we've already talked about. Now, what in the world do we mean by concavity or inflection? Well, let's take a look at our graph here, and let's start drawing in some tangent lines. So I'm going to go along my graph and draw in some tangent lines. Okay, there they are. And now look at the tangent lines. Particularly, look at the tangent lines in this part of the graph. To start with, they're kind of steep, but they're flattening out. And then as you reach your relative max, the tangent lines are basically 0. And now they start going downwards as the function starts decreasing, and they actually start decreasing quicker. So we can actually say numerically that the slopes are getting smaller. Starting out, they're positive numbers, but they're getting flatter, so they're smaller in the positive direction. And then once they're negative, they're starting to get a little bit steeper. And so they're smaller in terms of their bigger negative numbers, so numerically they're smaller. And then at some point, though, which actually happens to be right around 0, things start to change. Now, if you look at those tangent lines, the slopes, to begin with, they're negative, so it's decreasing still, but it's not decreasing as quickly. Right? Those lines are actually starting to flatten out. So, and as negative numbers get to be smaller absolute values, that's actually a bigger number. And of course, as we pass the relative min there, right, it starts to increase now. And you can see they're starting to get steeper. So we can mark in red the places where the slopes were actually getting smaller. And we can mark in blue the places where the slopes were getting bigger. We give a name for the points, places on the graph where the slopes are getting smaller. We say that's concave down. And that's because if you look at the graph, in relation to where the tangent lines were all falling, they were all above the graph. So the graph is down from the tangent lines. So we say it's concave down. In places where the slopes were increasing, well, if you look at the graph here, the graph actually falls above all those tangent lines. And so we say that the graph is concave up. And again, to help you see that a little bit more, let me take the shading away. And you can see when the slopes are getting smaller that the graph is down from the tangent lines, or concave down. And that when the slopes are getting larger, the graph is up from the tangent lines, so we say it's concave up. And you can kind of remember this visually. Concave up, if you abbreviate that, you get a cup. Right, and so you have to be above. It has to be able to hold stuff. So if it's concave up, it's a cup. You can actually put stuff in it. Whereas if it's concave down, well, then you just got a big old mess if you try to pour stuff in something that's concave down. Now, if it's concave down, the slopes are getting smaller. They're decreasing. Well, if something's decreasing, then its derivative must be negative. So something is concave down when the derivative of the derivative tells us the slope, so its derivative would tell us how it changes. So when the second derivative is negative, we're concave down, and then we're concave up when the derivative of the derivative is positive. In other words, when the derivative is increasing. So when the second derivative is positive, we're concave up. And then there's this one little point here in purple that I've marked, and that's called an inflection point, or a point of inflection. And an inflection point, or point of inflection, is where the concavity changes. In this case, it changed from down to up. So it's kind of the second derivative's analog of relative maxes and relative mins, except the concavity doesn't care whether it's going from up to down or down to up. We just call it a point of inflection. Okay, so this was an introduction to give you a rough idea of how concavity works and what it is. In the future videos, we're going to actually do the calculus analysis on this function, y equals x cubed minus 5x. So stick around for that video. It should be coming up very soon.